you guys can see my screen.
Yep, we can see it.
Oh, yep, thank you. So this talk will be sort of like a preamble to the hands-on exercises. And the reason we are having this kind of like a walkthrough of the installation right away is because, there can be few issues with logging into AWS instance or with installation. So we just want to make sure that by the time we get to the hands-on, everyone is ready. The instructions are available in the bootcamp website. So if you go to flow.ai/bootcamp, you should see a link with the instructions to install and run FlexFlow on AWS. So we can just go to that. We don't really have to go into the hassle of logging into AWS and on that. Let me actually download and so that it's a bit bigger. So we can skip ahead to page 6 to section 1.1 here, which is connecting to the AWS instance. So as Jihao mentioned, I believe you have received an email with instructions to log into your AWS instance. If you have not, please let us know. So you can either unmute and let us know, or post it in the Zoom chat, and one of us will get to you and help with logging into the AWS instance. So if you have, it is pretty easy to log in. If you're using a Mac or a Linux user, then use your terminal. If you're on a Windows machine, use your favorite SSH client, whether it's PuTTY or Git Bash, or what you prefer. So all you have to do is just SSH, use your first as the username, and the AWS IP address along with the region should be sent to you via the email. So use those instructions and SSH into the AWS instance. Okay. Are there any? Okay, some people seem like, it seems like some of them have not received the instructions. So hopefully one of us in the FlexFlow team can reach out to them.
Yep, so okay. I'm sending them the instructions.
Yeah. Okay, installing FlexFlow is pretty straightforward. So you can download this F document and follow along, and I'll also try and walk you through installation of FlexFlow. So FlexFlow has the following prerequisites. It obviously uses CUDA and cuDNN. cuDNN, if you're not familiar, is a GPU-accelerated library of primitives for deep neural networks. And it uses Legion for task-based parallelism. So Legion is a data-centric programming system, and FlexFlow primarily uses Legion for parallelism. And it also uses Google's protocol buffer, which is a language and platform neutral mechanism for serializing data structures. And optionally, I think I mentioned this in his talk, FlexFlow uses Nickel, which is NVIDIA collective communications library. It provides primitives for GPU and multi-node communication and networking. And FlexFlow can also use GasNet, which is an independent, like a middleware layer that provides high-performance communication primitives for stuff like memory access. So it is pretty straightforward to install FlexFlow because we have a pip wheel. So all you have to do is just do Python 3.6. This is specific for your instance. So, we're just saying we want to use Python version 3.6 -m pip install FlexFlow. And, it should install FlexFlow and all the related dependencies. And I also have the harder method that is using Makefile to build FlexFlow from scratch. And I'm planning to walk you guys through this because, you might have a hardware architecture machine in your institution, and our pip wheel might not work on that machine. So I'll take some time to walk you guys through installing and building FlexFlow from scratch, so that it'll be easier for you if you go back to your institution and try to build it from scratch. So the first step is to, let me bring up a terminal so that if you guys are following along, it will be easier for you as well. Okay, hopefully the font size is big enough. Okay, the first step is to clone the FlexFlow repository. So you can do clone. As I mentioned, there are prerequisites and dependencies. So do a recursive clone so that we will pull along, any dependency we have. So we already have all the dependencies in the repository as submodules. So that is why we do a recursive clone. So we do. We'll specify the path of the repo, that is github.com/flexflow and flexflow.git. Okay. I think I already have a repo, so I'll just give it another name. And take a minute or so to pull submodules with the dependencies. In the meantime, are people following along? Are there any problems logging into your AWS instance or anything else?
Looks like people are still waiting for emails from Jihao with the details, Vinay. So.
Oh, okay. And seems like some people aren't able to access the website.
Yeah. Can you also paste the link to the PDF into the chat?
Yes.
Thanks.
Yeah, so for the hands-on exercise purpose, you can just use pip to install FlexFlow. So this is just an optional method that I'm showing you guys, so that if you have a system architecture that is unconventional, then you can just build it from scratch. Okay, looks like we have cloned our repository, so we'll go into the FlexFlow directory, and we have to export a few variables before running our make command. So one of the primary things we have to export is the FlexFlow home directory, that is this current directory. So the variable is called ff_home. And because I'm already in the FlexFlow directory, I'll just say print working directory. Right? So essentially, my print working directory is in my home directory /FlexFlow. So make sure to use your custom path. So if you have a different username, mine is Ubuntu, so yours will first name. So make sure to use that specific path and don't just blindly copy mine. And the other thing that we have to export is the cuDNN and CUDA directory path. So we'll export the CUDA directory. So to find out what is the CUDA directory, we can just do which NVCC on this Amazon instance, and there is a symlink in user local CUDA, so we can just export that path. So I'll do export CUDA directory equal to user local path. Oh, sorry, CUDA. Okay, and my cuDNN directory is essentially the same. So I have to mention that the AWS instance that you are on already has most of the dependencies installed. That is, you have CUDA, cuDNN, Nickel, and protocol buffer. So you don't have to go build everything from scratch. So it makes our lives a lot easier. So we'll just export the cuDNN directory here, and that will be same as my CUDA directory. And the next thing that we want is we want to point FlexFlow to the Legion runtime. So inside your FlexFlow directory, you can go into Legion, and there should be a folder called runtime. So we want to export the Legion runtime directory and point this to this particular path here. So I'm already in this directory, so I'm doing a print working directory on that. And the last thing that we want is the protocol buffer. So on the AWS instance that you're on, there are two versions of protocol buffer installed. One that comes with your Ubuntu installation, and other one with your Anaconda install. So we'll point it to the Anaconda package because when I tested it previously, that seemed to be more stable. So in order to do that, we'll just do export protobuf directory equal to it. So the instance that you're running doesn't have a copy of Anaconda in your home directory, so you can just point it to home Ubuntu path that I'm just showing you right now. Ubuntu. Okay, now we will add this protobuf directory to the system LD library path so that it is available during runtime. So we export the protobuf directory /lib because we want the libraries in the LD library path. And we will just prepend that to our path. Okay. And once we have exported all these variables, the build process is fairly straightforward. Okay, before that, I forgot to mention this. So when you run your make, FlexFlow goes and builds for every GPU architecture that is listed. So to make the build process faster, we can figure out what is the GPU architecture of the GPU that is available in this instance. So in order to do that, we can just do NVIDIA SMI and see what GPUs we have. So it seems like we have 8 Tesla KE GPUs. And if you know what the compute architecture of NVIDIA GPUs, Tesla K80s is 3.7. So we can export GPU architecture or GPU arch variable as 3.7, stands for 3.7. And then we will be mostly using Python bindings for FlexFlow. There is also a C++ interface available, but I think in the hands-on session, we'll be mostly focusing on the Python part. And I think most of the machine learning development happens in Python these days. So we'll build the Python bindings. So to do that, go into the Python directory, and all you have to do is make. And please ensure not to do make my J here because you're sharing your instance with 4 other people, if I correctly. So maybe do like J2 or J4 just to be considerate. And looks like I have already built this before. If you're building it for the first time, it should take a minute or so. But essentially, this is all the steps that you have to follow to build FlexFlow from scratch. And let me go back to my PDF here for a minute. So once the build process completes, either you might have installed it using pip or followed along me to build everything from scratch. you can test whether your installation is complete or by running a very simple MNIST example. So we have different examples pertaining to Keras, PyTorch, etc. So I have provided an example script here, which you can copy and paste. Please note that this example uses Keras pre-processing, so you can install that using pip or Conda or whatever. I think the Conda build does not work with the instance as of now, so I recommend using pip, but you can use whatever method you want in your institutional computer, and then you can just copy and paste this. So essentially, that's what I'll do now, just to test if my FlexFlow build is incorrectly. It did not paste correctly, sorry.
Hey, Vinay, just to let you know, there's a few folks who are having some problems building with permissions, it looks like, and some other things. So I don't know if you want to handle that when we make it to the interactive session later on in the day, but just be warned that not everybody was successful there.
Yeah, so we can also have that during the hands-on exercise later. So after we have Vinay has finished his talks.
Yeah, after this talk, one of us can help them while other talks are going on, so we can help them in the background. Or when the hands-on session begins, we'll definitely help you and get things going. So I'm just running the MNIST example here and pointing it to the right directory. Control MNIST. I think it's called mlp.py. And then there are a bunch of command line flags that we have to pass. So let me actually go ahead and show you guys what those things are. So FlexFlow accepts different command line flags along with the arguments that you pass to your Python program. So there are a bunch of things like FlexFlow training flags, where you can specify the number of epochs or batch size and or print frequency, where print frequency is just basically at what frequency you print the output, and also specify the path data set, etc. So these are pretty self-explanatory. If you have any questions, just know, and you should be able to go through it and understand what things are. And along with that, and there are also a few legion-specific runtime flags. So a few of the important ones are /llpy, which indicates how many number of Python processors are running. So if you're running a Python program, you have to specify -llpy as 1 because you want to run FlexFlow on that Python program. And you can specify how many GPUs to use. So -ll GPU indicates what is the number of GPUs to use per node. And along with that, you can also specify the amount of device memory that you want to use for your ML training. So this LL colon F size is the size of device memory on each GPU, and you're specifying that in megabytes. And similarly, you can also specify the size of zero copy or pin memory, which has direct access. The GPU essentially has direct access to that section of memory and DRAM. And even that is specified in megs. And this is helpful for prefetching your training images or training data from the disk. And there are also other things such as LL:CPU, which shows the number of data loading workers. And there are some Legion-specific flags for optimizing the Legion processes, that is util and BG work. I think the first few are the most important ones that we will be using today. Along with that, there are also some performance tuning flags, like you can specify the search budget and some hyperparameters associated with the search procedure, which is the alpha variable. And you can also point it to the, point a path to where you export export your strategy, your parallelization strategy, and also you can import a pre-saved strategy into your FlexFlow training. So for running this MNIST example, I will use a few of those. So one of them, as I said, is I have to specify the number of Python processes. Let me see if this works. Okay, yeah. So the number of Python processors is 1 because this is a Python code, and I want to say that I want to use 1 GPU. This is a very simple example. And I want to specify the device sizes or the memory size on the device. I'll say F size is say 10,000, and my zero copy memory size or Z size is let's say half of it, and this should technically run. Okay. So we are running the training on a simple MNIST example using the default parallelization strategy available to FlexFlow. And yeah, looks like it will run to completion. I also want to mention that we also have a Docker repo itself. So if you're having trouble with the install in any way, you can directly go use Docker. So CD into the Docker folder and do a Docker build and mention a tag, say FlexFlow version 1, and then point it to the file. So I'm already in the Docker directory, so I'm just saying current directory here, and you should be able to build a Docker image. And because it uses NVIDIA GPUs, you have to use NVIDIA Docker run to run the container. So you can do NVIDIA Docker run and just specify the tag as ff:\v1 or tag you used here. Yeah, I guess that's it for the walk of installing FlexFlow. I see few people are having trouble, and I will address it as possible, and we'll get you going before the hands-on session. All right, any questions? Okay, I think we can move on to the next talk.
Oh, wait, I think you are muted.